Hey, this is Mr. Ward, and this is Geometry Do Now 25.1 Video Key, and here we go. So I've got this funky little figure here. There's plane M, and we've got this triangle here, PBC and QBC, and there's a line P to Q, and A is on that line, so that is a straight line. PA and Q are collinear, and A is the midpoint, and we know that PCB is congruent to QCB, and we're supposed to prove that line BA is perpendicular to line PQ. So how could we, there's some things we probably need to do to get there. Like, how could we prove that triangle PCB was congruent to QCB? Because that would help us, because if we could do that, then we might have a piece of triangle PAB and QAB, which gets us on the way to proving that this is perpendicular, which we'll get to in a minute. But how could we prove that triangle PCB and QCB are congruent? Well, let's consider the things we know. We've been told that PC and QC are congruent. We've also been told that this angle here is congruent to this angle here. PCB and QCB are both congruent. And then furthermore, BC is itself. Okay, so we can do that. So we can say, because we have been given that PC is congruent to QC and that angle PCB is congruent to angle QCB, and BC is itself, okay, by the reflexive property, okay, we can say triangle PCB is, goodness, I'm having a struggle typing here, is congruent to triangle QCB by side angle side postulate. Okay, and that's going to give us some useful stuff. Okay, for example, it's going to tell us that PB and QB are congruent as well. So we'll be able to say PB and QB are congruent, and that's going to help us with these triangles over here. All right, so let's keep going. All right, so it's the fact that A is the midpoint of PQ. Tell us about PA and QA. Well, it tells us that PA and QA are the same. And earlier, I noted that PB and QB are congruent. Okay, and you should be able to get some more stuff out of that in a second. So it tells us that PA and QA are congruent, okay, because that's the definition of a midpoint. Now, we got all this information. Let's sort of consider this. So based on what we've sorted out so far, how can we prove that triangles PAB and QAB are congruent? Well, we just noted that PA and QA are congruent, and we know that PB and QB are congruent because of kappa Kadika, corresponding parts of congruent triangles from PCB and QCB, so we know that. And then your old friend, the reflexive property, tells us that BA is congruent to itself. Okay, so because PA is congruent to QA and PB is congruent to QB, and then because BA is itself reflexive property, you can say triangle PAB congruent to triangle QAB by side postulate. And then there's a follow-up question. What can we say? What does that tell us about angles PAB and QAB? So it tells us by Kappa-Conica that angle PAB is congruent to angle QAB. Okay. So we can say all of that stuff. So we can now say that this angle here is congruent to this angle here. And you might notice that they're adjacent to each other and therefore supplementary to each other and therefore right angles. So based upon what we know about PAB and QAB, that they are congruent and adjacent, okay, because angles PAB and angle QAB are congruent and adjacent, they have to be 90 degrees each. Okay, because they are supplementary and congruent. Okay, because they're supplementary, they add up to 180. If they're congruent, two things that add up to 180 that are the same are 90 degrees. Therefore, BA is perpendicular to PQ, because that's the definition of perpendicular. It makes right angles. So BA here has to be perpendicular to PA, because that's a 90-degree angle right there and right there. We could also go on to prove that AC is congruent as well, because we have enough information to do that if we wanted. We could go on to then prove that PA or PQ happens to be perpendicular to plane M, because there are two distinct lines that, by using all the same stuff we just did here, there are two distinct lines that would allow us to prove that that are perpendicular to PQ, that would allow us to prove that PQ is perpendicular to plane M. But that wasn't the question for this one, but it's useful to take note of that. I hope that was helpful to you.